I just got back from the multi-cloud mashup, or as I've also been calling it, multi-cloud madness, here in Columbus, Ohio. And oh my goodness. Jim Kittle from The Ohio State University delivered an amazing talk where he highlighted OSU's cloud migration journey from way back in the 2014 days when they were on-premise to when they first started migrating to AWS and some of the challenges that they encountered, and maybe adopting some radical architecture changes for their data platform, but then transitioning to Kubernetes to roll their own on-premise Kubernetes cluster where they were able to host Apache Airflow before branching out to AWS. And then finally, expand into a multi-cloud using Microsoft Azure. Jim provides deep insights into the build versus buy evaluation of rolling your own Kubernetes or leveraging managed Kubernetes offerings from one of the hyperscalers. He also highlights key points of friction that organizations often incur as they start adopting the cloud, maybe by applying the wrong technology for the wrong job, learning from that and making adjustments. He also provided a very practical and pragmatic approach to automation, where you start organically, a little bit at a time, taking one step after the other, rather than boiling the whole ocean and trying to launch everything day one. I really appreciated their approach in automating their EKS environment using the AWS provider of Terraform, and then later automating their AKS environment using Terraform as well. The way they applied the same lessons that they learned in automating on Amazon, AWS, and terraforming that environment, and bringing those learnings forward to when they eventually automated the same environment using totally different services on the Azure platform, using a totally different Terraform provider, the Azure RM provider. This highlights the fact that when you use a cohesive tool like Terraform to apply your infrastructure as code across platforms, those same skills, those same knowledge, the same mechanics that you learn and optimize on one platform can be applied on the other platform, even if you might be using different services and ultimately different resources and different providers. He also had good insights about leveraging Helm to automate Apache Airflow to Kubernetes. So many things about this talk that provide deep insights across the spectrum of disciplines, technical and non-technical problem spaces that we as technologists often encounter. If you haven't seen this video or you weren't lucky enough to be present tonight, I highly encourage you to check out this video, listen to what Jim has to say. It's great stuff. Anyways, without further ado, here's Jim. Navigating the multiverse, right? Yeah, cruising with a multi-cloud data platform from The Ohio State University. So thank you, Jim. Take it away.
Sweet. Thank you. Thanks. So I'll just jump into it. The talk that I'm going to do today is very narrative-based. I'd like for it to be engaging, so I'm going to ask some questions of folks here. Please feedback. On the mic, I'll repeat, just so folks online will be able to hear. But again, this is meant to be an engaging conversation, and it's narrative-based. So who am I? First and foremost, that first line, I've had questions when I got reviews on this. Raise your hand if you are an architect or have the title architect, anything around there? Okay. You guys might know this, but have you heard of the term kind of ivory tower architect? Somebody who sits atop, spews frameworks and rules, and might not know what those frameworks and rules really mean.
Oh yeah.
You don't count.
Yeah. Oh yeah.
That. So me and our team, a lot of them are here. We pride ourselves on not being that. We pride ourselves on being very kind of tactical level architects, keeping up to date with things, actually doing things. So when we do come up with frameworks to help others, it's very realistic, and it's coming from experience. My background, I have a long history of integration, been in the integration space for a long time. First job was working for in the automotive industry, writing C# web services and SOAP. So not to date myself, that's SOAP. So whoever doesn't know what that is, I'm sorry, we can talk after. Beyond that, I've done some work in the security space, application security, different SaaS, different things around that. Automation, over the past 10 years, obviously automation and everything, why we're here today, have had some experience in that. And cloud native things, our team got into cloud native pretty early, some of the teething era, I'll say. Some of our current initiatives, which we'll get into here, but focuses heavily around data solutions. Our team is the data and integration enablement team. So with that, that could be APIs, that could be analytics, things around that. Beyond that, outside of work, I'm married, I have a wife, have kids, 2 kids. They're actually out in the rain right now, braving the elements to save Girl Scout cookies. When I'm not doing that, I'm usually trying to work out when I can, doing jujitsu. When I'm not doing that, trying to play music. Not good, so don't ask. And then when I'm not doing that, just generally being outdoors. So obviously this weekend when it was beautiful, I was at the park for 4 hours with my son, just trying to soak it up. So, backstory. Hopefully you're not expecting demos. They're not going to really be demos. This is, like I said, very narrative based and kind of what we did, why we did it, where we started, where we're going. So to look into that, I chopped up mainly the past 9 and 10 years into larger milestone blocks. So with that, going back to 2015, that's when I joined the team. Glenn's here. You can talk to Glenn after. But with that, the team was really standing up what we call within OSU the Enterprise Integration Platform. That's where our main stead was to work to abstract away all these APIs. There were a lot of different ERP APIs, a lot of point-to-points. So with that came different struggles. So with that, and what does that look like? So the Enterprise Integration Platform, this was, again, 2014, 2015, going through finding the different APIs that the business needed. A lot of those could be coming from ERPs. Our main ERP at this time was PeopleSoft. So a lot of those were delivered APIs, could have been APIs that were custom made and made available. So at this time, there was a lot of point-to-point, and I'm not sure if you could think about it as if there were 5 services, and those 5 services need to be accessed or used by 5 different people. You'd have to do like firewalls and management for each and every one of those things. So adding a layer of abstraction on top of that was easier management, and it gave us a lot of other efficiencies, like democratized access, things like we're talking about here. That's where there's a little call out here, if you can see it. Soap, a lot of pain with soap. So with this abstraction layer, that's where our team was given the stead to stand up this enterprise service bus. We used the open source technology by WSO2. And with this, that's where we would be the abstraction layer for SaaS products. At this time, there weren't too many yet. A lot of direct database connections. That could be your PeopleSofts, our space data. We have friends here who do that. And different on-premise apps. So that could be apps like user-facing apps, like our OSU app was a really big user at the time, and things of that nature. So with this platform enabled us to get a lower code solution. It wasn't no code like drag and drop, but we had tooling to be able to do that for maybe developers who are newer or haven't done API development, and it really gave us a good velocity and control around that. So moving forward, what did that look like at the time? This was our initial deployment. Again, 2014, 2015, Kube was very new, not really on it was on our radar, but something that wasn't like on our plate of things to do. We just needed to get what we needed, we needed to get that work done. So we had, of the tool set, we were using binaries, in essence, a VM. We had a VM through our data center. Ohio State has their own data center, so it's like our private cloud. So we had VMs stood up there, and everything was done, TLC through SSH. So there wasn't really scripting. To stand something up, we would SSH deploy in the goods, SSH in to take care of it. Things go wrong, SSH. Initial adoption, we had around 50 services at this time. So the web services, APIs, different things around that realm. We had some adoption through third-party vendors. The vendors that could do it, we would help them do it. There were some vendors that we worked with who actually helped rewrite code to do APIs at the time. A lot of fun around that. And again, kind of the framing or the data domains of which we were working with were HR, finance, student, all PeopleSoft. So moving forward in time, so with that 3-year period, there was increased adoption, more people on campus, more developers wanting to do APIs, more developers getting interested in it, and just the enablement itself, it was an early success. We hit a point in about 2017, 2016, where there was a decision to move ERPs from an on-premise PeopleSoft for HR and finance to Workday. Raise your hand if you work with Workday on a data level. Nobody's smiling, okay. Workday's a good product, it's great. There are different pains that come with integrating with it, getting small amounts of data in or out. Again, Workday isn't a database. We've had philosophical discussions with some of their product team of what does that mean, like data should be structured in a certain way. So with that, to get data in, again, services, to get data out are all web services. So we had what was a lot of direct database connections, a lot of on-premise connections that went to everything API. So if you weren't doing APIs, now's the time. We got to get everybody up to speed. So that's everybody across the academic side of OSU and everybody across the medical center side of OSU. So those are two different entities. If you did not know, they're under the same umbrella, but very different in operations. So with that, we were given instead from our leadership team to come up with a solution to make our API platform more reliable. And at this point, there was a concept of kind of, if you think tiering and support, like a tier 1 system is very important. It needs as many resources as it can to get up. We were given instead of this new level of tier 0. So we were meant to be next to the network. If we go down, obviously everything data in and out from transactions, if that goes down, there are problems. So if these web services, to kind of frame it, if there's an invoicing or a purchase order type of API and there's a surgery happening in the OSU Medical Center, a lot of that equipment is bought and purchased at the time of the surgery. It's not purchased ahead, they don't have a big inventory. So if that service is not reliable, that could hold up a surgery. So bigger things are at stake here. So that tier 0 really meant something. So what we did next was what our project team or our team coined as EIP Next Gen. So looking at the prior state, again, very simple VMs, had a management database, it was MariaDB, everything is on-prem. Our next move to make this tier 0 was 1, moving to Kubernetes, and 2, having 2 different deployment paths. So one of them was in our OSU data center. There is just firewalls and security. It just made more sense to have a presence there. And then at this point also get what we were considering like a disaster recovery or reliability zone that's up in AWS. At this time, there weren't a lot of the nice products that we have now, like EKS, AKS, and Azure. So this was all, you gotta roll your sleeves up and get it done. Who here does Kubernetes? Ish, cool. How many folks have rolled Kubernetes the hard way? Okay, yes, Kelsey Hightower. Like if you want to go look up Kelsey Hightower, look up Kubernetes the hard way. That's actually how we rolled and provisioned both our on-premise and our OSU data center Kubernetes. So with that comes, for those that don't know, the things that get hidden with a lot of the services now is there's an etcd cluster, which is like a key value store. You have to get that stood up. It has its own certs, and then they need to be signed a certain way. The control plane of Kubernetes itself, and it needs certs a certain way. And the Kubernetes worker nodes, rinse and repeat. It needs certificates a certain way. And with that comes a lot of management overhead. So while we get the benefit and capabilities of Kubernetes, dynamic scaling, all the reliability, there is kind of like a heavy cost of management, which we live through. And then with that, we got the AWS side of it stood up using EC2 containers and doing in essence the same thing, but just on EC2 containers in AWS. And to kind of frame why we used AWS, that was, there might have been pockets at OSU that were using different public cloud providers, but at this point, from like a strategic perspective, our first major agreements and kind of business agreements at a OSU big organization level happened with AWS. So that's just the public cloud that we had available. We used it, and it worked for us. On like a technical note of what was happening here, beyond the EC2 containers, we had a RDS MariaDB and obviously VPCs and all the magic behind all that. But at a high level, we had Route 53 health checks happening on our on-premise deployment. So if certain things weren't reliable there, it would just switch things to AWS. So it was a very hot type of deployment pattern. Moving on. Question. Pardon?
Do you have database replication?
Database replication. So the question was, did we have database replication? Yes, we did, and it was mainly through like, we worked through different open source solutions for like a MariaDB syncing, I can't remember the name of the product. It was an open source product where the product itself was where you could have like a hot type of database setup. We went through a lot of tinkering, filtering, what I want to say, but we went through some things that didn't work. So in essence, we just had like it was mainly on the database level, like an active and then being replicated to. So there would be like a micro period where the replication was happening from the on-premise to MariaDB where things might get missed. But at that we wouldn't have really been impacted by that because at this time our change rate in which we were deploying APIs wasn't very like, APIs weren't getting deployed every hour. So the backup rate and the sync rate would have handled our deployment rate, which was mainly, like at that point, I think we were doing once a week. So does that answer your question? Cool. That's your one question for the day. Thank you. Moving on. Beyond this, so this is getting into the 2019 period. Our deployments of Kubernetes were successful, both on-prem and in the cloud. And then this became a time of change. So with that, framing 2019, our mainstead was integration and enablement and enterprise architecture. And in that time between 2019 and 2022, we had a leadership limbo, leadership carousel, if you will. So with that, you can imagine when you're making big strategic decisions, the leader that's maybe leaving and coming in doesn't want to commit to something, and they want to leave that for the leader coming in to give them, like a clean plate. So with that, we had in that limbo state some of our change rate, some of our upgrade rate, different things that got impacted on that. And our level of where we were innovative really got stalled. So Workday happened. Some of our product upgrades didn't stay up to latest greatest, so we fell behind in products. And then beyond that, in making any other bigger decision, like deploying how we do things in the cloud and the costs associated, we were told for a while to hold on, we'll wait until the new leadership team happens. And mind you, this is, in that period is obviously a big one as COVID was happening and digital changes were afoot. So we had, during this period while we were in this limbo state, we had an increase in our services. So obviously data needed to be moved at a faster rate. So agility got very important. So our work queue increased and how we delivered things increased, while at the same time our budgets got reduced. So fun challenges. Jump forward to 2022, our team merged with the data and analytics team. So at this point, we were actually two separate teams. So again, we were enterprise data enablement or data integration enablement, and this is the data analytics team. Kind of, you would think like Realm, same things, but we were kind of two tribes doing different things. And at that point, it was very trying, I'll say, because we operated on two different kind of thresholds, two different rule sets, and now we're one big happy team. So jump forward to 2022, merging of teams. The biggest thing on that, how the data warehouse worked, like from an architecture perspective, we were involved in that, from analyzing it, doing solution decisioning, kind of from capabilities of what the data warehouse tool needed to do. And at about 2014, that's when there was a shift from some of our on-premise data warehousing capabilities, and there was a strategic decision to move to AWS using Redshift, and that's where a lot of the workloads of that grew. And then with that, there was some complexity. So at a very, very high level, this is what that architecture looks like. A lot of S3 buckets, which acted as our data lake. The data integration and scheduling capabilities, I like to kind of package all those together. A lot of that was a mix of Lambda, Glue, and SNS. And there was a homegrown app that was created. It was novel for the use case. It was, obviously, we had to pull all this data from Workday, which is all web services, so we needed to do that in an efficient way, because you can't just ask Workday, give me everything about everybody. There's a lot of pagination and different things that had to happen. So with that came management overload, so the data engineering team at the time came up with a tool to handle that. So there are some gotchas with that. Who here works with Lambda at all? Has anybody thought about using that for data integration? Considering it has a 15-minute limit.
Yeah.
you can see where we're going. So with that, our high-level architecture for what the data warehouse looks like, it uses a medallion structure. So there's a staging, a bronze, a silver, a gold, and each of those levels, as they go up, there's a higher business input on what that is. It goes from like a raw data to actually having like business input and filtering and business logic put into it to be more business actionable, and then reporting and visualization on top of that. So with that, moving forward, this is now part of our team, a part of our kind of responsibilities of how we need to look at things, reverse engineer it, and moving forward, as we looked under the hood, there was a lot going on. There was a lot going on. What would take, you would think for a typical troubleshooting on a data job fails, wouldn't just be go to maybe this code base, go to this code base, make some changes, touch it up. Because of that asynchronous nature of how everything was happening, you had to go kind of like 10 levels deep to see, okay, here's where it's failing, then I need to go 5 levels up to fix it. And in the meantime, the business is asking for, hey, my reports are wrong. Can I get this fixed now? So there's a lot of troubleshooting with that. And then beyond that, that wasn't any one person or any team's fault. That's the same thing that happened with us, to where our use cases grew and our budgets got constricted. This team had major attrition with that. So like what was like a team of 10 went down to like a team of 3. So, you know, keeping the lights on was just keeping your nose above water in essence. So with that, we found that there was the S3 bucket structure and some of the architecture around that. We were somewhat over leveraging how S3 is set up and kind of what we were paying for as you're using it in S3, and then what we were actually paying for in like a reserved instance type of setup in Redshift. So that's where, in that, there are some different things where we're looking for areas of improvement. One of the biggest things from a developer experience that we felt like we needed to improve was like the onboarding of new data sources. So in that, if you're a new data source, you want to get data into the analytics environment, and you want to get that to a report to some executive, the time in which it took to do that was not fast. So not only at that, the development time to add to that asynchronous product that we were talking about before, but then you were constricted to only files, had to be dropped on an S3 bucket, and it had to be CSV. So if you're a more modern app that has APIs that the data is available, here's your access, you know, like go fishing, just get what you need to get. You were kind of constricted to where you had to fit the mold of how the product worked versus working with, you know, where teams are at. Yes, so moving forward onto the current day, present time, 2024, this is where we're talking about the data platform, a larger data platform approach. So to kind of cut through that onion that we were looking at earlier, we broke that down into really 3 major deliverables. The first deliverable was where there was a Lambda, where there was Glue. We also had some products I didn't talk about that other major data things happened, like 3 other products that were on-prem, 2 of those out of support. Let's steer the boat in the same direction. Let's all row the same way so that we can have, you know, efficiencies that go along with that. Another major thing, that's where we chose Apache Airflow to be that solution. And then beyond that is improving observability, reliability, all the good things that go with kind of having everybody walk at least in the same path, in the same direction. Beyond that was improving the new data source onboarding, meet devs where they're at. Like I said, it's great if you have an API, but it's bad when somebody says, I like your API, but I want that file. So that's where being able to consume APIs and just make the onboarding and developer experience a lot better. And then on the back half, obviously one of the most important pieces is cost efficiency with our constricting budgets. Scrutinize what we're using, how we're using it, is it the most efficient use, add bucket policies, clean things up. Don't have jobs that drop buckets in 3 places and then leave them forever. Clean that stuff up. And then just generally how we ingest data into that medallion structure, improve it. If we're going to have it sit in files, could we just write it to the staging? Do we need to really go to staging? Could we just write it right to the bronze layer and then go from there? So this is all cool. I know everybody came here to hear about history, hear about Ohio State and some of our pain points, but here's how. So at a high level, this is kind of our broad deployment. Obviously, not a lot of detail. The big bucket items are here. The first hurdle with us deciding that we were going to move to Apache Airflow was we need to get this up. We have an on-premise Kubernetes cluster that we're already using. It's performant, so we will just start there. So with that, this is a new tool, a new product. We already have things that are running out there right now with our WSO2 suite of tools and our microservices. So how can we easily get this out as fast and as reliable as possible? So that's where the quick decision was to, in essence, let's Helm. This is what Helm does. Package management, let's use Helm. So what we used, who here uses Apache Airflow? Anybody? Ish? You don't count. There's people on our team, so they're being funny. So with that, Helm, what is Helm? Helm is a Kubernetes package manager. It gives you a very great way to deploy a suite of tools. So like Apache Airflow at a high level is made up of a web server, a scheduler, a DAG processor, which the DAGs themselves are the data job or the data pipeline themselves to ingest them, and then different worker nodes. So like you could have a node that's sitting there that's constantly doing work. How we chose to deploy it is using, right now, a Kubernetes executor. So every time a DAG runs, and that DAG can be made up of many tasks. Every time there's a task, that task will spin up a pod, do its job, and then go away. So you don't have overhead of just a server sitting there not necessarily doing anything. We're learning some pain points with that as well. So there's, for common jobs, it might be okay. But when you have long-running jobs running on the same infrastructure that maybe jobs that run maybe once a week, twice a week, you get some lack of efficiency. So that's where there's a Kubernetes Celery executor. It's a different executor type. We're going to be looking to move to that in the very, very near future. So with that, the Helm itself, configuration deployment, configuration-driven deployment, and then with that, it's agnostic to where you're going. So you could have one configuration set agnostic of where you're going. So we're going to use Helm. Helm is going to give us our deployment playbook, if you will, for all those different pieces of Airflow to deploy on-prem Kubernetes. Doesn't matter, we just give it the targets, change the configuration just as much as if we go to AWS, if we go to Azure. So we have that one central place to manage how we want to deploy Airflow. And these links, if you care about those, I have a slide at the end where they're all at the end. So at a high level, what does this flow look like? Again, Helm has a values file. That's in essence, the high-level configuration. And you can piece out different parts of that for your more sensitive things like your secrets. But at a high level, we'll just say a values file. So what happens, we pull the Helm provider down. We have the values file. We configure what we want. We want to use a specific Mirai database. We want to have these components turned on in this way. We want to have the Kubernetes persistent volumes, its state set up this way, and then we have all of that in one file. So you can have Helm deploy directly if you considering you have your kubectl. I'm not going to get into the kubectl debate here, but kubectl. If you have kubectl configured where you're running Helm, you can deploy with just Helm apply right to your Kubernetes cluster, and it will do all of the things that are in that Helm chart. So we found that the Helm chart that is curated by the Apache project itself, the Apache Airflow project, which is great, and it, in my mind, raises the confidence of what the capabilities of this thing are because it's so co-located to the core project. Were some things that it didn't handle where we had to take a step back and say, how do we want to do this? I don't necessarily want to jump into the Apache project and say, hey, our little special thing, I want to add it to there. So that's where we punted that to customize, which customize is the vernacular for it is Kubernetes native configuration manager, which in theory, if you like pain and you have a lot of time, you could have did all of that in customize. So it's like a templating for kubeyamls where you can just kind of hot patch different pieces into there. And that's where for the specialness that we needed to do on the end of this, we did. So that's where from a deployment flow of Helm, we have it doing Helm plan. It outputs the Helm, that Helm out YAML file is in essence, if you would open it up, is like a huge thing where it's all the kube service accounts, the deployment, the pod specs, everything about this deployment for our deployment of Airflow is happening. So that's where we have some customization patches happening. And then with the K argument and kubectl, that's where you will apply those changes using customize. So that's where it's kind of like a two-stage deployment plan. Any questions so far? That's a lot of stuff. We got a little more to go, but a lot more to go. But questions so far? Anything? Cool. Yes.
How are you actually managing versioning of all of this? It sounds like you're kind of changing how you're doing it and that you're moving across technologies pretty quickly. Do you have issues of like losing previous versions, or when somebody leaves, or things being deployed manually, programmatically? Like, how are you handling the change management?
So how we handle change management on this, it's a great question. That's where it's like, I didn't want to go on too many tangents, but on this, like all this is version controlled. We have an on-premise GitLab instance. All this is version controlled on there. And then the specific values files and things that are sensitive is in our privileged access management tool, which it's secret server. It was a Thycotic product. I don't know what it is now. Andy, who runs that, was supposed to be here. He might be online right now. But with that, that product itself was actually looking to integrate with Vault, HashiCorp Vault. That's where we're working on different things to have like automatic secrets. Like it's the central solution of that privileged access management tool could do like secret cycling, like changing passwords, and then have obviously go to Vault and then automatically update the goodies and the secrets config maps in Kube. That was just one of those things. Like we need to get this thing up, and then we can come back and touch that up after we're done. But that's definitely on the roadmap. So like Git versioning is like our main source control for all of this. And then I try my best to do. We all try our best to do heavy documentation, so it's like you go through like a flow state of getting this module done, then like while it's fresh, markdown, get it all in the markdown, have somebody else read it and say, does this make sense? Are you able to, is this coherent sense? I know the guys in the back will laugh if you ask them about some of my markdowns probably, but yeah.
I had a question.
Yeah.
This Helm flow, it's interesting you got this two-step process where it seems like you're using kind of a Terraform, like almost like a Terraform plan where you're outputting the YAMLs that the Helm is going to generate,
right? And
then you tweak it a little bit using Customize. Is this a manual process, or do you have this set up? You mentioned GitLab. Are you using Jenkins? I mean, like, what pipelining tool are you using?
That's a great question. For this part, for right now, this is a manual process. There is a script that does some of the specialness that we have, special scripts.
Specialness.
Yes. But that's where, like, again, we're just trying to get the thing up. And then for kind of like our tempo that we have, our step one as soon as it's up is we're going to go back and have this be in GitLab runners. That's for any of our CI stuff. We have some Jenkins. We have a Jenkins presence for some of our legacy stuff, like our WSO2 products. But we're trying to get everything more into GitLab runner. So then the code, everything's in one place. So you get like one viewport of all of it.
And did you look at the Helm provider for Terraform?
I was actually going to talk about that.
Because okay.
Yeah.
Then
at a light level, where that's like on the radar of things. So like once we get into like, at this point we're not even in time. We're not even at Terraform yet.
Yeah.
Love like what we're doing. We're just trying to get up Airflow, get things going.
Get up and running.
Yeah.
Okay.
So moving forward, at this point it was running on-prem, everything's great, release the data engineers. Here's some data engineers doing their data engineering stuff. The guys in the back breaking it. Yes, question.
A simple question. So I see the Kubernetes cluster, you work with Helm flow, and can you also use AWS with that? I just use ChatGPT, so the Kubernetes developed by Google. But can you combine with AWS from Amazon for the cloud and data management together?
I'm trying to understand your question. So from like, are you asking like Kubernetes on AWS itself, or?
How you use AWS and Kubernetes together to manage your data?
Oh, yes. So we will get to that.
Okay.
But wait, there's more. Yeah.
Make sure they don't fight each other.
Right. And that's where kind of what's happening at this point, and that's, I think we're going to get great segue. What's happening at this point in time, the data engineers are running this on our on-premise cluster, but if we talked about before, this is a multi-tenant cluster, so there was a lot of stress that happened on our on-premise cluster, which we kind of knew was going to happen, and then we learned some things from that. So like a wide view of what's all running on our on-prem Kubernetes cluster. We have Airflow running on there, but we also have our WSO2 stack, our API stuff, and microservices, and a couple of other things, to where we had a fixed number of nodes, because we have VMs in our data center, and then Kube running on that. So this is like, in a point in time, we don't have the AWS EKS up yet.
I had a question. Sorry, you mentioned different nodes. How many different node pool types do you have in your on-prem?
Oh, that's the beauty of it. We don't. We just have fixed nodes.
So it's fixed nodes everywhere.
Yes.
Okay, interesting.
That's part of the problem.
Because that seems like it would be challenging
Very.
in an on-prem environment. Because in Amazon and Azure, we have the flexibility of adding different node pools with weird SKUs, right?
Yes,
So-
which is something we wanted to do, but that was because of that leadership limbo. Like we're dealing with the cards we have right now. Yes.
Did you define fixed nodes in this context?
Yes. So fixed nodes meaning we work with our server team and our infrastructure partners to say that we want this many clusters. They provision us VMs. They're RHEL VMs. We stand up the Kubernetes cluster on those, and then that's what we have. Our dynamic kind of flexibility on that is more, we want more compute, and that's about it. So if we actually want to add more nodes and expand horizontally, that's us making a request to get another VM and then add it to the cluster.
So by fixed nodes, I just to clarify, I think you're talking about each node has the same and a uniform number of cores.
Yes.
And a uniform number of RAM.
Yes.
Whereas in cloud environments, you have this ability to spin up additional node pools, tag your deployments in Kubernetes to that need the GPUs or something, and be like, yeah, send those guys over there, send you over here. But here we've got a party cluster with uniform nodes.
Yes.
You said there's manual scaling. It takes like a week to approve, and you're running out of compute. And
I wish it took a week.
Okay,
A week,
so
yeah.
you have new compute, and you're out of compute, and everything's on fire.
Welcome to on-prem, folks.
Yes.
Okay, that makes sense.
So that's the
Back
world.
to speed.
Okay. Yeah, because there's a lot of moving parts. Yes, question.
Forgive me, I'm relatively new to these topics.
Yeah.
I keep hearing this word Kubernetes. Could you explain to me, not like I'm 5, but maybe as if I'm 10 or 12?
Yeah. So do you know what Docker is?
I'm sorry?
Do you know what Docker is, like containers?
I do not.
So think of, at a very high level, a container, like how a developer could say, it works on my laptop, like with the old adage, so you just ship the laptop. So like you would package an app in like a container, and it needs to run somewhere, but that's just a single container running. So, run that at scale, and you need reliability, and you might want that thing to scale horizontally on its own. So Kubernetes is a container orchestration platform. So if you have that compute, your app, say it's a web app, just for easy example, you deploy that web app on Kubernetes, it has its own deployment, and here's the compute, or not necessarily the compute, but I want this thing to have 2 pods running at all time. That's like the most granular level in Kube. I want 2 pods running. There are some services, so it's going to abstract out the compute, it's going to abstract out the network, and it's going to abstract out the storage. Okay. So then you could have like NFS possibly as a persistent volume is what Kubernetes calls it. So then that thing, if a pod goes down, it'll automatically bring a pod back up. Or if you have different horizontal pod scaling rules, you could say if this thing gets really taxed, CPU hits this, I want it to go out to 5. It could do that. Does that help?
So it's a lot of making things work across many different forms of hardware.
Yeah, it's kind of like if you think of it like that, to me, like that's where just philosophically abstracting out those things. So like the compute in Kube would be pods, deployments, replica sets, stateful sets, if you will. We won't get into that, but and then on the other side there are services. So then you could expose those pods through different network mediums. It could be node port, like an actual port on a node out there, or use load balancers, which if you're running a public cloud, it could actually spin up an actual load balancer for you that you can manage.
Could I try one?
Go.
Have you ever seen Harry Potter?
First 3.
Okay. You know what the night bus is?
Yeah.
It's that big bus that expands and shrinks depending on how many people need to ride it. Kubernetes is kind of like the night bus, right?
Okay.
You need 30 people on your bus. Come on, guys, hop on. Boop, it expands.
Yeah.
You don't need that many. Boop, shuts down. Okay. Kubernetes is the night bus.
Except that his is set up so it can't expand or shrink, and everything's on fire.
Except on premise, there are certain limitations in the night bus, but
It's not practical. Okay.
yeah.
Question about that.
Yeah.
With the fixed nodes, does that mean that is your Kubernetes infrastructure set up so that you can still allocate and scale across those fixed nodes, though,
Yes.
right? It's not contained to certain regions.
Yes. So how our cloud services team has a different service set up to where they have a huge node pool, if you will, where it's the fixed nodes vernacular, but it's that, and then there's different baked in Kube security to where it's multi-tenant. So it's just the container service is node pool, and you'll have your slice of that. And then it's kind of like namespace segmentation and all that. To where for our workloads, we wanted to have our own dedicated compute. So that's where we have our own. So it's working under that model, but just for us and like our nodes, if that helps.
On a party cluster, just like the night bus, everybody gets their own bunk, right? So you're all sleeping together in the same room. It's not that great. Some people can snore, you know.
Hopefully they wash, you know.
Yeah, and hopefully they use some soap.
Yeah. So at this point, we have obviously some issues happening. Jobs are running. There's some cross impacts. So the blast radius isn't great. So that's where we wanted to change how we're deploying things. So that's where we have space, we have an AWS instance, we have work that needs to be done in that Airflow where the target of those data jobs is all Redshift. It's not going anywhere else. We have a large set of jobs just going to Redshift. So our logic of that was, let's get up Azure, let's get up Airflow there, and then we can, you know, prioritize. Like that's our first fire. Let's get this off here so we can get the workloads in Redshift working. So with that, we're diving into AWS. We had some experience with AWS. We had the other stuff that was already set up for Redshift, had its own VPC. There were many hands in that pot and many different approaches to configuration. So that's where the cleanest cut for us is we were just going to do our own VPC. We were going to have that in the same account, but kind of a different slice. So just segment it off over here. They were going to interface. So with that, that's where, of the laundry list of things we needed to do, obviously set up the VPC. There is a direct connect, so how OSU has it stood up, there's a direct connect to where we just use a transit gateway, connect to that account, and we'd have private IP space. So that helps us for the private IPs and databases we needed to connect with from a firewall level, we were able to manage it. And then the other laundry list of things here. So keeping in mind like deployment tempo, reuse, maintainability, and using the lessons learned from the former on-prem environment. So we questioned, like, is this a new onion? Are we going to have other problems of maintaining this big complex thing? So that's where Terraform, yay. So with that, obviously we have done some work with infrastructure as code. Like that's our whole team codifies everything. We pride ourselves on like codifying business logic for data jobs, codifying automation. So now we're going to codify infrastructure. Let's just keep the ball rolling. So with that, obviously gives us automation, gives us a way to have a map from like an architecture perspective. The first time I looked at how those jobs were set up with that asynchronous kind of back and forth, like my head wanted to blow up. Because I don't know if everybody else here with an architect title, like I like clean pictures where it kind of, you can easily paint the picture. It might not be super deep, but at a high level, like this is how the widget works. So this is a way for us to have all of that. Lessons learned pretty quick. We saw the benefit of kind of how you build a Terraform. What are you going to do? Like, is this going to be just, here's a below deployment, everything's happening, and it's like, wait a minute, we're going to need other databases. That could be a module. We're going to connect with other networks. That could be a module. So then kind of the modular approach of what we build and how we build it quickly came to light. So jump forward, the Terraform is complete. It's awesome. You push the buttons, all the things work. We have EKS set up, all the different pieces, all the security groups, the management database for Airflow, it's all good to go. And now, because we already had the Helm set up, we already knew what that needed. We already had the firewalls for different LDAP connections. We knew at this point we have a new database, new management database, just change the connection configuration for that and move forward. So then we have the specific AWS Helm values, doing that same Helm flow, deploy it, and Airflow go. And this is where in my talk I was going to ask, who here who does Helm? There doesn't sound like there's too many, but who uses the Helm provider?
For Terraform. The Helm provider for Terraform.
Good, bad, ugly, like real quick.
I like it, because it lets the Helm people, if you've ever looked at Go's templating language, I mean, talk about wrapping, duct tape around your head, because holy crap, it is a mess. So, you do you, Kubernetes world, you like that templating stuff. I can have a very clean HCL block to provision Helm charts, and I don't have to have some nasty deformed claw of a bash script, because that's like when I get a Helm chart that's being deployed, usually it's some nasty bash script, and then I'm just like, yep, convert that to a Helm chart, block in Terraform. Boom, it cleans it up. You can actually read it, and it's like, oh, okay, yeah, makes a lot of sense.
So of our continuous improvement things that I said we're going to get stuff up and built, like that's on that list of cleanup. So that nasty.
Can you list in the future, list that has happened?
So this is up and running now.
Okay.
There's other things afloat, so that's where of that prioritizing kind of getting the things up because we're still working on the Azure deployment, which we'll get to. That's where we're going to go back and change how our Terraforms are kind of specific to AWS, specific to Azure, but then have them do at a high level the same things. So that's where, as they deploy Helm, that's where we would use the Helm provider.
Yeah, and if just throw this out there, if you get more comfortable with HCL, HashiCorp Configuration Language, you might also consider the Kubernetes provider to replace all that customized stuff that you're doing. Because with the Kubernetes provider for Terraform, I mean, basically what Customize is trying to do is make things easy to like pipe into to Kubernetes YAMLs, which are essentially like just YAML documents. Like there's no dynamic things going on there. So unless you want to copy pasta into YAML, like you use Customize or use the Kubernetes provider for Terraform, it allows you to use Terraform to kind of pipe things into Kubernetes YAMLs. So
Yes.
just
Noted.
go ahead.
All good. So moving forward. Oh, sorry. Question.
When you were
Going back.
Terraform, did you have to go and just declare everything that you wanted to use, or did you have some method of kind of like importing it?
So with that, it was a very organic approach, I'll say, because we were figuring it out as we go, So with that, it was at a high level, like it's not a domain-specific language, but it has its function. So it's like, we'll learn the intricacies of that, but it's like, what do we need to get up? So it was kind of like that, let's go through the deployment path, design it, even manually deploy a couple things just to see if there's any nuance with that configuration, then very quickly turn that off, put it in Terraform, deploy it again, and then have the Terraform state be managed.
I've experienced the organic adoption, so I was just curious if there was another.
Was your approach different or better, worse?
Doubt it.
But it's very like you're kind of figuring it out as you go. It's like true developer experience where it's fun. It was fun. I really enjoyed it. So moving forward, if we're looking at that kind of high level view, it's a stress system, systematic sigh of relief. So that's where this is also in process. So of those jobs, we're getting the biggest, heaviest pain points, and we're starting to slowly move them into the EKS cluster. With that, we found some different intricacies with kube versioning. Different things with how our on-prem Kubernetes cluster is working and how what was working isn't now working in a better, kind of more secure state. We'll just leave it at that. So working through some of that. So now the newer operational challenge is we have these 3 different deployment paths for Airflow, and if they're all going to be the same or are they all going to be different, so then like the imaging, because we do have to touch up an image because of some of our package requirements which is happening in Airflow. Does that need to happen in all the environments? Does that need to happen in one? So that's where, like, an example of that is we use DBT for some of our data engineering jobs. So we actually build some DBT pieces into the image itself. So like, we're not going to use that in Azure. We're not going to necessarily use that in on-prem. So maybe that's the AWS golden image. So then image management of that stuff. So it's just different things that we need to consider now. So what's going on in Azure? So this is a bigger item that kind of outside of that, framing what we were talking about before, that analytics environment, that was very much more historical. Analytics workloads should not be operational. There were some operational things happening, but that's where it's mainly analytics and then visualization on top of that. So that's like your reporting, your Tableaus, Power BIs, what have you. So this is meant to be our home moving forward for the enterprise data layer. So there's been a lot of work, there's been a lot of design meetings we've had. So this is like going to be our new hot ticket item, so to speak. Very big impact. What that is at a very high level, our enterprise data layer, it's like an aggregation layer for data that needs to be reused operationally for different things. So that could be person data from an ERP, that could be some stuff from the student system, maybe some buildings data, some different things that are all coming together that if you were an app team and you needed to do that, you'd have to connect to all those APIs where we aggregate that for you and then make it available. And then if there's different data validation things, we get a lot of tickets for that from person type of data where there's different sources for person data where we present it and there might look like a data issue. People come to us and then we go do homework. We've been doing it for years. It's like, EIP's down. No, EIP's not down. Like, what service are you talking about? The person service, okay. This data's wrong. Okay, well, we go look at the actual source and say Workday or PeopleSoft, and it's like, well, there was maybe an HR business process that didn't happen, and we're just the presentation layer of that problem. So that's where at this layer, we're gonna add things in there to automatically kind of look for that and then message, say, that the HR steward, data steward, to say, hey, we found some anomalies, some inaccuracies, you might wanna look at this. So that's where that's gonna be happening here. And so with that, obviously we want to have Airflow helping do that. And this is where long-term, we were looking to more so have all the pieces running here. There's still some, what we do with Redshift, which is above my pay grade. There's some bigger conversations happening around that and what will happen there. But for this, we went with Azure because our on-premise version of this right now is a Microsoft SQL Server. And again, time to market, tempo, get it up, get value. So we already have hybrid licensing with our agreement with Azure. So it was just, we can just deploy it there. We're already hitting issues with other data jobs running and hitting this SQL Server. So again, we'll get immediate elastic, scalability, reliability, things of that nature. So the value is going to be very quick. So jumping into the Azure side of the house, rinse and repeat all the same type of deployment things that we're having happen in AWS. And the biggest thing here from me in an architecture perspective, I don't know if anybody else is like this, I loathe vendor lock-in. So being able to adapt and have more than one solution for a thing and being agile, like that's where having a presence in AWS, good, having a presence in Azure, good. Then all of this is cloud native enough where we could, there'd be effort, but we could pretty easily pick up things and move them where we want to go because we never chose a managed solution for these different pieces. And for this, we used Azure RM provider. Again, we had already built out the AWS version of this, so there were some lessons learned, modularize what we need to modularize, and then move forward. We did find some interesting things on how our org account was set up to where our org team, like the overall Azure management team, termed off some things, and our Postgres didn't deploy. And then we had some interesting back and forth with Azure support, and them helping us and then saying, you need to turn this thing on. Then we had to talk to our cloud team and they said, this needs to go through a risk review. And it's like, it's a first party app. And then kind of that back and forth of fun. Yes?
So you're talking about a separate cloud team. So is your team application and DevOps? Or is there like a separate DevOps? Or is there also some other team that just pays the bills and turns off random features that they're worried about?
Kind of like that.
Oh, okay.
Yeah. So there's one team that manages all of the and kind of helps people with AWS because that's had a longer presence at OSU. There's another team that runs and manages the Azure instance, which we do Entra ID, and there's different things for like how our domain is set up. So they've been in that realm a longer time, so they manage that. Okay. So they're more like the storefront for getting
subscriptions.
Yes.
Passes them off, but puts like training wheels on them and limitations so you don't just accidentally deploy a managed key vault which costs $5,000 a month.
You can still do that.
Oh, never mind.
But I think it's more like from a third-party app perspective, turning things off that might be like, Jim Kittle's app, trust me, turn it on.
Yeah.
Like
data security stuff.
Yeah.
Okay.
And in Azure, there are not all resource providers are enabled by default. Jeff, I'm looking at you. AWS is probably the same. I mean, there's probably certain services besides thinking about SCMs, right? Like you probably have certain services that need to be manually enabled.
Yeah.
Like Google Cloud's kind of the same way. But it's even more obnoxious about it, in my opinion. Like you got to manually enable every damn API on Google Cloud. But anyways.
So hitting some of those fun.
It might have been that. Was that it?
It was technically a first-party app, but it's like, what do you consider first-party? It's a Microsoft developed app that was required for the Postgres flexible server to be deployed.
Oh,
Because when every time we go to deploy it, we just get internal server error, and it's like not very helpful. So what do we do? But we ended up getting it fixed and deployed. So long term, what is happening here, we're getting, and again, an Azure AKS up. We're having Postgres. We're getting Airflow deployed there, and that Airflow's workload is going to be holistically dedicated to moving data to that enterprise data layer. Of that is obviously a Microsoft SQL Server. We have some different on-prem kind of static databases for historical things for Postgres, and then we do have some NoSQL solutions like Elasticsearch that we do for some of our backends for APIs, looking to kind of build those in a different, more reliable way. Different mediums for all of this. Yes. Why? Question.
Cost savings by doing this?
Cost savings? Yes. It's more at this point. It's mainly more cost avoidance. So for us to get up more nodes on-prem would cost more than us doing what we're doing in cloud.
Yeah, I guess I'm wondering, are you reducing your footprint on-prem?
Yes.
So cost saving.
Yes.
And then that's being slightly offset by whatever it's costing in the cloud. So I'm kind of curious, do you have a feeling for what the offset is? So you're reducing, say you had 2 VMs, you only need 5, that's $500 saved on-prem. You're spending $400 in AWS, you're really saving $100, right?
Yeah.
Do you have an idea?
Not at liberty to say. Not at liberty to say. But yes.
Have you also been able to set up the cloud environment to scale so you're not actually using it all the time? So are you saving a lot of space on like empty nodes through 2 a.m.?
Yes, so like with this, that's where we have like node scale groups in both Azure and AWS, where we have it like at a 2 to 5 right now, where it's like for this workloads that should manage, but then beyond that, that's where it's something that we're not going to talk about here. Airflow makes available different things for KEDA, K-E-D-A, which is like, what is it, Kubernetes event-driven architecture, where it can be smart enough to actually scale to 0 if you allow it. It'll give it time to learn, and it will actually scale down to 0. So that's where it's like, again, once we get the stuff up, we can start doing different levers and trying to make it even more efficient. So of this, the different things where we're finding that we need to think about is having a better path for distributed development of Airflow DAGs themselves, because this is an Airflow specific thing. Airflow, the project itself, is great if it's just for your team. If you want to have other developers from other teams come in, the access model is not great. It's pretty much, once you're in the door, you can see it all. Like they don't really have a multi-tenant solution yet. The Apache project itself has been actively working on that, and they've been making headway, but it's not there yet. So then with that, as we build this platform, another capability of the Azure specific side is going to be distributed development. So if it's a different business unit that wants, it has a capability of developers who want to do DAG development, get data into this enterprise data layer, we want to enable them. So have a good developer experience of different CIs for automatic deployment, but then you can see your DAGs, you can go into Airflow UI and look and see, are things running, are they good? Right now we don't have that, so that's where we're trying to, how do we do that in a good way that's efficient? Work with secrets management, because again, if you get in there and you see it all, that's all the connection strings of what's ever in there. Like you could kind of limit that in a way, but like you probably just want to see your connection strings, and then me from that security hat side, like I just want you to see your, like what you're allowed to see, like least privileged. The other side of that can be an issue is worker segmentation. So while these are running on nodes, it's that kind of pool party. What was the vernacular you used? The nodes, like where it's everybody.
Oh, the party cluster?
Party cluster, yes.
Yeah.
So this isn't necessarily a party cluster, but this is whatever's running on here is going to hit the same node set, where we could have dedicated node groups and then have those tainted to go just run on those nodes. But then that's where from our operational side, like we need to be able to carve out to say, business unit X, you want your own nodes? Cool, we'll spin them out and then have that bill kind of, you're paying for what you use, here you go. So worker segmentation, and then back to that other side of just fine-grained access control. Like once you get into Airflow, like you shouldn't be able to see everybody's DAG. If it's like an important DAG pulling stuff about like people, like home, location, different things. We don't really work with HIPAA necessarily, but we do work with FERPA, which is a regulation on financial things. So it's like you are legally not allowed to see this. So we need to be able to segment off who can see what. So that's where things we're going to be working on. Talked really fast about a lot of things. Future capabilities. We're going to be looking into event-driven architectures. So everything we're talking about is very batch-heavy. Airflow is a scheduler, go-do thing on a cadence. It can handle event-driven things, but should it? Probably not. It's like one of those kind of use case questions. So we're going to be looking at different mediums for that. Bigger thing is, again, enhance the distributed pipeline development. That's a key thing to make all of the people across campus happy, or stakeholders. Like, having been a developer, I'm sure everybody here has developed at some point with a crappy developer experience. Like, you quickly, if it's water and there's a rock in the road, the water's going to go around the rock. So like, don't be a rock. Be a free-flowing river. And then beyond that, there is obviously the hot ticket item of large language models, chatbots, things of that nature. There is some work that has already happened for chatbots on OSU. It's still kind of, the strategy of how to manage that is in flight. So thinking about that from a less public data perspective and a more institutional data perspective, protected data, if this hub and this enterprise data layer is going to have all of that data, how do we make it available in a manageable way for people to build a RAG off of or something? So that's kind of stuff that we're going to be building and solutioning for in the future. Summary, like I said, we talked about a lot of stuff really quick. So data pipelines, Apache Airflow, infrastructure as code, velocity, reliability, go. I do want to give a big shout out to our different teams that we work with. Our infrastructure team, our cloud services team, our security teams who worked with us and partnered with us to really innovate through a lot of this. And they've never been like a say no. They see the value of this, and it's like, well, let's learn together how we can all operate. And that goes to that kind of DevOps mentality where everybody's been great partners. And then the biggest shout out goes to like our data engineering team, who's been there's two of them in the back. Big shout out to them for kind of riding with. It's been great. Questions? Yes.
As a software engineer, not a infra person, I'm kind of curious, what's your self-service offering like?
Self-service. So right now, it's because it is, from our API store perspective, we do have a marketplace, like an API store where there's a conversation of obviously use case, like, and then the APIs are available. You can go see what the APIs are, and then if it's like a sensitive data domain, that's where it would go to a data steward, just get approval, and then you can you have your OAuth application, you're allowed to subscribe to this. From a data perspective, that's where there's more of a workflow. From the analytics side, everything's driven by a report. Like, we shouldn't necessarily be aggregating data if we're not going to report off of it. It's like you're just aggregating to aggregate and spend money. From the enterprise data layer, that's where we will build. The primary use case for that is to have API, that'd be a backend for APIs and operational systems, event-driven stuff. So that one is going to be in flight. So that's where we're paving that path right now. So does that help?
Yeah, and I was also kind of wondering, just from like the pure like infrastructure perspective, it's like, you know, I'm working on an already established application, right? And maybe I want to spin up like a like separate process node from that, like almost like a fork of that application, right? Things like that. Just curious, like whether that's something like you even have to worry about, like whether that's something that teams are coming to you for, is like, hey, like we want to be able to more easily spin up like smaller services that don't necessarily need to tie into like anything new or need to have access to any of these sort of like data integrations right off the bat. But purely just from like the, you know, application level like infrastructure.
So from that, and that's to the enterprise data layer, that was like a challenge we were given by our CIO, was if it's an app that doesn't have a home, and we need to, like velocity, we need to develop and get this out because there's some business value right now, that it will be, that the whole design of that is to be a home for that if that data needs to be used or aggregated with other things. And that's where, say you need to get person data, like just build it here, the person data is here, so we will help with that, tying it. Where if it's maybe like a one-off app, where it's just a super segmented use case and very specialized, not edge case, but you know what I mean, like nothing else is really going to need this, that would be kind of more, we could help you, but that's kind of more like you would have to get your own database and stuff, and we'd help architect it, but then that would be not on our infrastructure necessarily, if that helps.
Any more questions, flag me down. I got the mic here, so.
Yes.
Is the goal to eventually move entirely off the on-prem Kubernetes?
Yes and no. So that's where I think a majority of the majority of the jobs, yes, to have that elastic scalability, but that's where, back to those design principles of not being overcommitted to one product. I think we'll always have an on-prem presence. Like that, we could consider that like an edge node that does specific things. Like there could be specific use cases for, say, like our medical center, which they have a much different infrastructure footprint and like hardened footprint to where we could help them do things that might be an on-prem and that kind of their subsect of the infrastructure. So I think it might be use case to use case, but I don't think we'd ever fully go away from on-prem, if that helps.
So how do you plan to manage then these clusters in different locations with EKS, AKS, on-prem? You mentioned they behave differently based on where they are.
So that's where very quickly we learned the version skew and the Kube API. For those who don't know, the Kube API accelerates very fast, changes very fast, deprecates very fast. So that's where having not like a specific strategy, but like having a thought of like, what is LTS to us, like a long-term support, like we're gonna pick this version and ride it out until this version comes on. Then that would give us a more manageable way from a Kubernetes perspective to say, here are the breaking API changes, we can test them, and that's where that on-premise cluster would actually be great use. So that would be like kind of like our own engineering cluster to blow stuff up and not make anybody mad. Oh.
Question.
Yeah. Yes.
There you go. Sweet, thanks. Yeah. So for your Kube deployments, you were talking mostly about Airflow. Are you moving EIP to Azure and AWS as well? Like the actual APIs? And if so, how are you going to manage that? Are you doing like a service mesh? Like,
out of scope. Next question.
Ask us later.
Uncomfortable questions.
No, there's a plan. I don't think anybody wants to be here till 9, so yeah.
Drake?
Yeah.
I just want to run more.
I got to work off that pizza, man.
So you talked a lot about technological process for this, but a lot of these decisions end up coming down to kind of people. Mm-hmm. So what changes have you made that have been successful in terms of team dynamics? Like, has it been just standard agile? Has it been, what kind of things have you done with the people that are approving the budget and the hirings and firings? Like, what has happened at an interpersonal level? Because it sounds like around 2022 things start going from like downhill to uphill.
There was stability. So that's where we had a dedicated leader. We had convergence of kind of capabilities on the different teams where it was like the API team and the data team where it's like, we're all data, just moving a different way. So as that came together, there was a lot of, I would say, how things were built and that team's experience and how our experiences was from an API perspective. And we were already doing data things with the enterprise, the early versions of that enterprise data layer. It was pretty much like take the good from each and merge it.
Okay. So it was just a pure like cross-group communication.
Yes, and that's where we all report to the same person, that guy right there, Glenn. And that's where we championed ourselves. We have always championed ourselves on being just big on collaboration, never like putting up walls. So having that organic communication, talking about things like, just thinking about this, is that good for you? No, here's why, and then kind of meeting in the middle. If that helps. Yeah.
One more right here.
Yeah. So as a senior architect, part of your job is getting buy-in from developers, just feeding the trough. Can you describe your communication strategy to getting buy-in from older developers who may be on different systems, different processes, and are new developers who are not used to Airflow?
This guy, thanks. So with that, there's obviously challenges with communications of people at various stages career-wise, because obviously somebody who might have done things a different way, like not using necessarily cloud-native technologies, having that be a concept, there's some selling that goes with that, so it's kind of championing it. It can be challenging. I mean, sometimes that's where it's like the 80%, 20% type of thing, where if 80% of the team is good and 20% is not, it's like, unless there's a great reason, I think we're going to probably go with the 80% on this kind of design decision. So there's always conflict. Like nobody's going to ever, I don't know if there's ever a team where it's just like everybody's great, let's go, blah. Like.
So how do you sell Airflow?
So how would I sell Airflow?
Yeah.
Tool commonization, like the tool unification. So that same developer who might be the statesman, if you will, who's worked on 4 different integration mediums and scheduling mediums, if they could have one viewpoint, why not?
Cool. Thank you.
I had a question.
Yes.
I don't know much about Airflow, but like, do users actually use kubectl, or do they talk to the Kubernetes cluster at that level?
They shouldn't be.
What's that?
They shouldn't be. That's a part of kind of like, we lightly coin ourselves a platform team, where that's like a loaded question. Like different vendors view that in different ways, good or bad. Where like our main stead is make the developer experience streamlined. Like they should be aware that it is running on Kubernetes from like a, how the sausage is made, but you don't got to go to the sausage factory. Like our CIs, our different automations will take care of that for them. And that's where it's kind of like the guardrails of the developer experience. You drop your DAG off here, you come with your artifacts, you put your secrets like in this place, the rest it'll take care of it for you.
I got it. So the identity model problem is more about Airflow and less about like the Kubernetes platform itself.
And that's more for like a developer as you're developing something, you want to see it run. Like you want that tactile thing. Like I wouldn't want to deploy something and have to go, hey, how'd it work? Call somebody or team somebody. Like where you could go in and actually see it. So that's where having that experience is a little better, where maybe in like if it's a stage deployment model or like dev, you can go in and play and turn knobs, where QA, not so much, definitely not prod. So it's like as that maturity of that development pattern happens, we could probably do that. But like I said, that's still kind of in flight.
Last question for me. For your AKS clusters, are you guys using Entra ID integration in order to admin that cluster? Again, how's that working out? No? Okay.
Not right now. Yeah.
Just curious.
Yeah. That's more other side.
Yeah.
Make it better.
Any other questions? Okay. Wow.
Thank you.
Like, wow. One more round of applause for Jim Kittle from The Ohio State University. Holy crap, man. Like, what a great talk. And thank you guys so much for coming out. I'm floored. Like, amazing work. Amazing work. And a lot of representation here from OSU. So thank you guys so much for letting Jim, give us the inside scoop on what's going on there. A lot of cool stuff. I mean, wow. Like, really, first multi-cloud madness, and you knocked it out of the park, man. Way to go. Anyways, I think that's the end of the activities tonight. Feel free to hang out, mingle, finish off the pizza, grab drinks. Thanks again, Veeam, our sponsors of tonight's event, for hosting us and for the wonderful pizza and for all your beautiful faces. Thank you guys for coming out and,
thanks for having me.
Being an audience for Jim. Amazing. Thank you.
Appreciate it. Great job. Thank you.